So far, we've created an agent, added a tool, and gave it memory. But it's still cut off from the outside world. A real agent isn't just a chatbot that talks, it should be able to read files, clone a GitHub repo, or write to a database. That's where MCP comes in. MCP is actually an open standard that allows our agent to connect securely to external systems. Everything is compatible, secure, and easily integrated. To provide a clear example and avoid any confusion, we'll first walk through this code sample from our tutorial step by step, and then go ahead and implement it together. In this part, we already have the weather tool we built earlier. Now to show how MCP works, we're going to add a file system MCP. With this MCP configuration, we can use different types of MCPs together with VoltAgent like STDIO, streamable HTTP, basically all MCP protocols are supported out of the box. So let's start by setting up a simple STDIO MCP server that can access the local file system. Let's briefly go over this. Here, we are actually describing how to connect to our MCP under the server file system. We specify that it will work through a standard output and input with type. In this example, we're going to use STDIO as the MCP type. Whatever MCP protocol you're planning to use, you need to define it here. In the args property, we specify which model context protocol server to use. We specify which folder it will work in and set a timeout limit. Thanks to this structure, our agent will not only query the weather anymore. For example, it will also be able to save text to a file. Let's directly take this and add it to our project and continue. Oh, and here we are using an async function, because MCP config get tools works asynchronously. So we need to wait for a while when running tools from an external system. This way, our agent can perform both weather information and file operations moment by moment. Now, let's test our MCP on VoltOps console. For example, let's say we ask the agent to get the weather and then save it to a file. We write the prompt, run it. It processes the request, calls the right tool, saves the file, and gives us the final result. Here, for example, we're checking out the events for the Get Weather tool. We can see that it took London as the input and returned a sunny weather forecast as the output. We can see all the tools discovered from the MCP server right here in VoltOps. Let's start by checking out the Create Directory tool, what parameters it takes, and what output it generates. When we look at the successful execution context, we can clearly see the inputs it received and the output it returned. Next, we'll look at the Write File tool. From the input and output, it's clear that the weather result was successfully written to the desktop folder. Thanks to VoltOps, we can see exactly which inputs and outputs were used by the LLM to trigger each tool, and that's helped us cut down our debugging time significantly. We can also see which tools were triggered right inside the chat playground, which makes debugging a lot easier. Now let's take a look at how to use the Hugging Face MCP server with VoltAgent. Our agent can now access the file system, but now we will take it a step further. In this step, we will see how to connect to remote AI models like Hugging Face over HTTP. Let's go back to the documentation right away. So, why HTTP MCP? Because MCP does not only work locally, we can connect to remote services over HTTP. Thus, we can also perform complex operations like file reading and image creation using our AI agent. We first log into Hugging Face and obtain the necessary API tokens. This step is essential for enabling access to their hosted models and services. You'll need to visit the Hugging Face website, generate a token from your account settings, and then securely add it to your projects.env file. Here's the new code block we're adding. It's the main change compared to what we had earlier. We connect the remote Hugging Face model here. Then, we update our agent's capabilities from here in the same way. As we did before, we are adding new features like file reading, image creation, language translation, summarization, and analysis. In other words, the agent is now top-notch. It can access both the file system and powerful AI models. So it's not just answering questions anymore. It's interacting with the environment, pulling in external data, and performing real tasks that go way beyond basic chat. All right, we are ready. Now let's copy this part into our code and see it in action. The development server automatically refreshed, and we can see the build was successful. So now let's head over to the VoltOps playground and test it out. We can come here and test these combinations in the same way. Now let's try out the MCP. We'll start from here and use one of the example prompts from the tutorial that generates and interprets an image. Just a heads up, sometimes the Hugging Face MCP server gets overloaded and doesn't return a response. That's totally normal. Alright, so now it started calling the relevant tools based on the prompt we gave to the Hugging Face MCP, and it generated the image and returned the response, including the analysis. Now let's head over to VoltOps and take a look at which tool calls were made. We can see that it made 2 tool calls, and we're able to look closely at the inputs and outputs, which makes debugging a lot easier. So now we've seen how to use MCP. In the next step, we'll explore sub-agents and start building more autonomous AI agents.